Yeah, we're good?
Yeah.
Go. Awesome. All right. In that case, we're going to get on with the lecture.
Wow.
Sweet. All right, so for those of you all at home, you can spotlight between the board and the slides. So you can jump between to see what I'm doing on the board. Also, I am recording this on a split screen so you can see both at the same time later. That's why that setup took so damn long. But last Wednesday, we were talking about lines. In particular, we were talking about slope. And I have said that slope describes this idea of inclination of a line, right? What I left out was there is a distinction between positive slope and negative slope. Positive slope tells you that as you move to the right, so as x increases, y increases with it. However, negative slope tells you the exact opposite. As x increases, y is going to decrease. Which makes sense, right? It's negative, something's decreasing. So having said that, a line that's in slope-intercept form is written as y is equal to mx plus b. So m here is going to represent the slope, and b is going to be the y-intercept. Why is that? Pun intended. It is because when we're talking about y-intercept, what we're talking about is when x is equal to 0, right? Zero b. So if this line is written in the form mx plus b is equal to y, when we plug in 0 into x, all that survives is that b term. So to get some intuition of what this equation is actually telling us, the b is going to be the place where we cross our y-axis. The n is going to be how inclined our line is. Having said that, I said there were two particular cases that we kind of consider to be special. The straight up and down case, we say the slope is undefined. And then this straight horizontal case, right? The slope is 0 here. So what's happening? Why is it that this case slope is 0? The first case, the slope was undefined. Well, it goes back to how slope is actually described, how it's formally defined. Slope, m, is defined as the change in y over the change in x. That's all well and good, except what the hell does those triangles mean, right? Those triangles, for the uninitiated and those who are not members of fraternities or sororities, those are deltas. And what they tell us is the change in a thing. So delta y is going to be equal to y2 minus y1. Delta x is going to be it's going to be x2 minus x1. Delta x is going to be delta x, yeah.
When we see the delta y's and delta x, it's always going to equal what's on the right side you bring?
Yeah, so all delta anything means. Delta whatever, right?
Yeah.
All this thing means is you're going to have whatever 2 minus whatever What?
Oh, I gotcha.
Does that make sense what I mean?
Yeah.
So all it's saying, all this means is it's math shortcut for the change of a thing. If we're gonna write this a whole bunch, we'd rather just be able to use shorthand. And that's all this is doing. This is just shorthand for the change of a thing. And the way we're describing this thing, in our case, we've got a graph, right? We're gonna say there's this line. On this line, there's going to be 2 points that we want to ask a question about. Let's call this point 1. Let's call this point 2. Or we can change the order if we wanted to. Well, point 1, that's associated with x1, y1. Point 2, that's associated with x2, y2. So if we want to know the slope of this line, we would say that m here is equal to delta y over delta x, or y2 minus y1 over x2 minus x1. Now, a point about this. It doesn't actually matter which comes first, x1 or x2, y1 or y2, so long as your numerator and denominator follow the same order. So if you have y2, y1 up top, you should have it down below. If you have x2, x1 down below, you should have y2, y1. That makes sense what I mean? Having said that, if we wanted to graph a random equation given let me say that slightly different. We want to graph a line given its equation. The first thing we would want to do is put it in slope-intercept form. And then go from there, right? So looking at this first example, actually, let's look at C. C, we're given that our line can be described with the equation x plus y is equal to 2. We need to put this thing in slope-intercept form. So we're going to subtract x from both sides. Now we're going to rewrite this a little bit, expand things out. What we really have is 2 plus -1 times x, right? So our slope here is going to be -1, and our intercept is going to be 2. Makes sense what I mean? So to graph this thing, let's go to our y-axis, identify where 2 is. I'm just going to put a bunch of random hash marks so we can say, all right, there's a 2 somewhere, right? In our case, 2 is going to be right there. We have a slope of -1. So for every unit to the right we move, we have to move down 1 unit. So it would help to have some sense of distance along our x-axis. Let's move over 1 unit. Now down 1 unit. We've got a point there. Let's move over 1 more unit, down 1 more unit. Now we're crossing the x-axis. Connecting the dots. The graph of our equation looks something like that. Of course, this isn't perfect because I just roughly drew it and could have been drawn better. But this is the general method of how we're going to go about graphing these things. We're going to try to put it first in that slope-intercept form. We're going to start with our intercept because that's an easy place to go to. And then we're going to use the slope to tell us how far over and up or down to go, right? So oh, that's because they were looking at the first one. First was like, that does not look like my graph, but that's because they were looking at the first example, which is 2x plus 1. And 2x plus, oh, thank God, AC. 2x plus 1, our intercept is going to be at 0, 1. Now we're going to go over 1 unit and up 2 because the slope is 2, right? And what the slope is really measuring is the rate at which our y values change as x changes. So, talking to my mom, she also teaches math. She likes to compare it to recipes. If you're going to make a dozen muffins and you need so many eggs, and now you're going to scale it up to 2 dozen muffins, the way slope scales your x and your y is the same way your recipe will scale your eggs to the number of muffins you make. Everybody get what I mean? So having said that, we had the other example, b, which is just y equal to a constant, right? Well, what this really is the equation 2 plus 0 times x, right? Make sense what I mean? So what I'm saying is, in example B, we could rewrite that as y is equal to 2, this thing can be rewritten as 2 plus 0 times x. So we have a slope of 0 and an intercept at 2, 0, I mean at 0, 2. So check it out, slope is 0, and we intercept it here at the point 0, 2. So getting everything into the slope-intercept form is going to be really helpful to us, just because it lets us relate a bunch of things that are happening in the graph all at once. And finally, that last case, the one that we actually worked out on the board, you see they kind of went the same route, right? They said first, let's put it into slope-intercept form. Then, let's identify our intercept. And based on that and what our slope is, we can figure out what the rest of our graph looks like. So from there, we can answer a bunch of other types of problems. So we have a physical example of just a inclined plane, or say a wheelchair, right? If we want to know what the slope of this plane is, we're going to have to first convert either inches into feet or feet into inches. Here it's going to be easier to go from feet to inches than it will inches to feet. And that's just because the way these values reduce, right? So we're going up 22 inches. That's our delta y. And our delta x is going to be 24 feet. But to put that into inches, we multiply by 12. Inches per feet. So what happens, this comes out to be 1 288, right? Yes, 288. $288. So the slope of this thing, since it's delta y over delta x, that's going to come out to be 22 inches over 288 inches. Pro tip, anybody who's left-handed, if you know you're ever going to have to work at a board, start figuring out now how to write on a board, because it really sucks sometimes. Being left-handed on a board, just want to erase everything. Anyhow, so to find the slope of this inclined plane, we're going to take delta y divided by delta x. We just said delta y is 22 inches, delta x is 288 inches. Dividing the two gives us the slope of that inclined plane. So this is the part where on WebAssign, you may be asked to give your answer in terms of decimals. Go ahead and figure out what the decimal is and put it in terms of that. But if you have to do something else with this, keep that fraction off to the side, because it might be useful elsewhere. Maybe later they want you to solve a particular equation. So let's say they tell you how far this inclined plane starts from a door, right? And they want to know some sort of an equation that describes this system. It might be helpful to go ahead and keep this off to the side is what I'm trying to say. Does that make sense? Yeah. Cool. So having said that, again, we can think of slope as a rate of change. That's really all this problem is trying to describe is to show this idea that slope does in fact describe the way one thing changes with relation to another. So in our case, we are trying to model the cost of producing an X number of goods, right? So our X is going to be the number of products, and C is going to be the cost of that production line. What we're saying then is that per number of products we're producing, each of them have a certain cost associated with that, plus whatever the initial startup cost is. In this case, $3,500. So what our slope is doing is acting like a conversion between the number of products to the amount of money it costs. So it is in fact a rate of change there. Does that make sense what I mean?
Wait, could you repeat that?
So because what this 25 is actually doing in our example here, 25 has this set of units associated with it, dollars per product. So when we multiply it by X and add this other value, $3,500, this X is the number of products, right? So our slope here, 25, it's acting like a rate of change, describing how the cost changes with the number of units produced. And in that way, we can think of slope as a rate of change. So just to reiterate a point that I had made a minute ago, the order of our difference, of our subtraction. It matters only insofar as we conserve the order from our numerator to our denominator and vice versa, right? So these first two examples totally work, but come over here, it fails because all of a sudden there's a negative sign where there shouldn't be one. Does this make sense to everyone? We can see that looking at these two examples, we have points 3, 4, 5, 7. Notice 7 and 5 associated with the second point. 3 and 4 associated with the first point, right? So preserving that order, everything works out good. But what happens when we change that order? What I mean is, what if don't do this. All right, what if what we did instead was write y2 minus y1 divided by x1 minus x2. In our example, if we're calling x1, y1, 3, 4, and x2, y2, 5, 7, then taking the difference in a different order, you're going to have 4 minus 7. Let me say 7 minus 4. And 3 minus 5. It's going to give us 3 over negative 2. Which is negative 3 over 2, right? So it gives us the negative of our slope. And this is why order actually matters to a point. Preserving it top to bottom, but nothing more. Everybody cool with this?
Yeah.
Make sense what I'm trying to say though? So we've already seen a couple similar ideas to this. If we wanted to find the slope of the line that goes through two of these points, or any collection of these points, we would just identify what our x1, y1 is, x2, y2, find the slope from there, right? Now, what if we wanted to find the equation of that line? What then? What I am asking is, what if we want to go from just 2 points to an actual equation for the line that goes through those 2 points? How do we do this? We would use what's called the point slope form for the equation of a line. We would say we have dummy variables, y and x. We're just going to leave those blank. We need to know our m, our slope, and then we need to know just one of those 2 points. So in our case, let's go back up here to example A. in our case, we have x1, y1 is equal to -2, 0, x2, y2 is equal to 3, 1. We've already found, going through this process, that m, our slope, is equal to 1/5. We know that because it's just the change in x over the change in y, the change in y over the change in x. So now we want to put it through point slope formula. But we know what m is. And at this point, I particularly don't like the notation they use. I'm not a fan of it, because it leads us to believe we have to use whatever we define x1, y1 as. But that's not necessarily the case. That's not true at all. We could use any point you know that's on that line. So we could rewrite this as using the point -2, 0. You could rewrite this as y minus 0 is equal to 1/x, or 1/5, x minus -2. Well, obviously that 0 disappears right away. That's convenient. So we have y is equal to 1/5 times the quantity x plus 2. We can go ahead and distribute this 1/5 all the way through. When we do, you get y is equal to 1/5 x plus 2/5. So let's go ahead and write that down. Y is equal to 1/5 x plus 2/5. So what we just did was we took just 2 points and found the equation of a line that goes through those 2 points. We started by finding the slope, and then with the slope, we informed our point slope equation and reduced it all the way down to slope intercept form. Is everybody cool with this? Now, what if we had used the point 3,1? Three, 1 minus 1 minus 3. Well, first thing we're going to want to do in this case is move that 1 over here. So we're going to have y is equal to 1/5 times x minus 3 plus 1. We're just adding 1 to both sides, right? Now we're going to distribute this 1/5 all the way through. Y is equal to 1/5 x minus 3/5 plus 1. Well, we can rewrite that 1 as 5/5, right? So let's go ahead and do that. This 1 can be rewritten as 5/5. So what we do, now what we get is y is equal to 1 over 5 x plus 2 over 5. Exactly the same equation. Notice the first way was quicker though, right? And it was quicker because our y value at that point was 0. If you see that happen, it's generally the better point to use. Because otherwise, you're going to have to massage some of the algebra that we just did here. So either point works, but as a pro tip, if you have a point with y equal to 0, use that one. Just makes the math easier to work out. Is everybody cool with this? Yeah. So point slope form, another example of it. Here we're told the slope is equal to 3 and it has to pass through a given point. So we would do the same thing. Now we don't have to go through all this mess. We already know what n is. So we can come right over here, throw m in, throw our point values in, and just solve. What that solution is going to look like when it's graphed, it's going to be something like this. They're saying the exact same thing. You already know what m is, you already know what your y1 and your x1 is. So just throw those straight through. Massage the algebra, simplify it, and put it into point slope or to slope intercept form. So, some general, just good things to know as far as equations of lines are concerned. The general form for the equation of a line is as so. I personally try to avoid using that whenever I can, just because it's not immediately obvious what the geometric details are, right? Like trying to interpret this geometrically isn't exactly the easiest. But this is, and this kind of is. So I generally don't use the general form when I don't have to. That said, we should recognize the rest of these. The point slope form, we should recognize because we're not always given all of the information we might want. We might be given just 2 points. And point slope form lets us work to the slope intercept form from just 2 points, or from 1 point in the slope. Then it's just generally good to know what the equation of vertical lines and horizontal lines are as well. Now, having said that, a question might come up, how do we know if 2 lines are parallel? Well, you know they're parallel if M1 and M2, so their slopes, if their slopes are equal. And intuitively, this kind of makes some sense, right? If 2 lines have the exact same slope, but go through different x-intercepts, then they shouldn't ever cross. Similarly, if 2 lines are perpendicular, they're going to be the negative reciprocals of each other. So, if, for example, using this example on the board right now, if I had asked a question, or if I asked a question, find a line that's parallel to this, all we need is another line with the same slope, but that goes through a different point. But that goes through a different y-intercept, right? So just 1/5x will satisfy, right? Because the intercept is different, but the slope is the same. Everybody cool with this? If, however, I ask for a line that's perpendicular, well, take the negative reciprocal of the slope, that's going to be -5 times x. That's all you have. So this line is parallel to our original line, and this line is perpendicular. And it doesn't matter what b we tack on to either of these. What matters is their slope. And that's what's important here. When talking about parallel and perpendicular lines, what matters isn't the b that you tack on, it's the slope. So if you're given a problem like, find the equation of this line, now find a line perpendicular to it, try not to overthink it. Just look straight for your slope, take the negative reciprocal, that's it. You can put on whatever b you want back here now. Similarly, for parallel. However, if they ask for it to go through a particular point, well, then you're gonna have to use the point slope form. Reduce that down. Does that make sense? So let's say I ask for a line that is perpendicular to our equation. And goes through I don't know, give me a good point. 3, 5. That's a good point. All right, to find this line, the first thing we need to do, say, all right, we want M2, our new slope, to be equal to -1/M1, our original slope. Our original slope was 1/5, so M2 is going to be -5. Now, we're going to use point slope form. We say, all right, we want 1 minus 5 is equal to -5 times x minus 3 adding 5 to both sides. We have -5 times the quantity x minus 3 plus 5. Distributing now. We have -5x plus 15 plus 5. It's -5 times -3, so plus 15. So the equation, the point slope form for the line that goes through 3, 5, and it's perpendicular to our original equation now, we just found. Is everybody cool with this idea?
Yeah.
Similarly, we would do the same process if it was parallel. We would just have these two slopes set equal to each other. Right?
So when it's parallel, it just means the slope stays the same?
Yep.
Okay.
Yep, that is all it means. But if you wanted to go through a particular point, what you would do is you'd go through this exact same process, except here, you would have the slopes the same.
Okay.
M2 would be equal to M1. So all the way through here, you would have 1 over 5, 1 over 5, 1 over 5, 1 over 5.
Gotcha.
Just to show, again, more of the same, they give us the equations of different lines, and then ask us to find parallel lines through a particular point or perpendicular lines through particular points, right? So just to show what it'll end up looking like. Notice our parallel lines have the same slope. Our perpendicular line has the negative reciprocal of those two slopes. Having said that, that is the end of that section. So I'm going to let us go out for a break and come back in about 10 minutes.